Ionic compounds are composed of metals and nonmetals, or anything bonded to a polyatomic ion. Now, on the periodic table, the majority of the elements are metals, and they are all over here, and the nonmetals are over here on the right side of the table. Now, some of these elements always form the same kind of ion. For example, all of the elements that are in group 1 here have one valence electron, and of course metals have a tendency to lose their valence electrons. The group 1 elements lose their valence electron and get a charge of +1. The group 2 metals have 2 valence electrons, which, when they lose them, give them a charge of +2. And over here we have aluminum, which always forms a +3 ion. Now, a lot of these other metals that are in here have more than one possible charge. For example, iron can be +2 or +3. Copper can be +1 or +2. And you do have a sheet with all of the elements, all of the metals that have more than one possible charge to use as a reference. Now, I want to write the name of these compounds. So the first question I have is, does the metal have more than one possible charge? And in this first compound, NaCl, sodium's a group 1, so it always forms a +1 charge. The second question I have to ask is it binary? Does it have 2 elements only? Or is it ternary? Of course, this is a binary compound, so I just name the ions and change the ending to IDE. You know this is sodium chloride. The next compound, FeO, iron can have more than one possible charge. We stated earlier that iron could be a +2 or a +3. Which one is this one that's in this compound? Well, I know that oxygen is always a -2. And since there's one iron paired with that oxygen, then I know that iron must be +2, because all of my compounds need to be neutral. That means that their charges have to add up to 0. So now that I've determined that this is iron +2, I'm going to write the name as iron, and then in parentheses, Roman numeral 2, oxide. Since it's binary, it's going to end in IDE. Next compound, CuCl2. Again, copper can be +1 or it can be +2. Now, I know that chloride is always a -1, and there are 2 chloride ions in this compound. And if this is going to be a neutral compound, then the charge on my copper has to add up to a +2. That's going to make this compound copper 2 chloride. And those are all binary compounds. Up here, KNO3 is a ternary compound, and that means that there's a polyatomic ion in there. So we use the same rules. If the metal has more than one possible charge, we need to indicate that with the Roman numerals. Otherwise, just name the ions. Now, I know potassium is in group 1. It's always a +1. So I'm going to name this potassium nitrate. Once again, we have copper. We know copper can be +1 or +2. In this instance, it's bonded to a sulfate ion, which has a charge of a -2. And since there's only one copper in the formula, I know that that must be copper +2. +2 minus 2 equals 0. So I've determined copper +2. I would write copper 2 sulfate. And the last one we have here, calcium is a group 2 metal, only has one possible charge of +2, so I just need to name the ions. Calcium nitrate. And now we'll go in reverse. We're given the name, and we need to come up with the formula. The first compound that we're given is aluminum oxide. So I know aluminum always forms a +3 ion, and I know oxide is just the ion of an oxygen atom. And I know that oxygen always forms a -2 ion. And so I need to make this a neutral compound. In other words, the charges need to add up to 0. Now there's two ways to do this. The long way, which is come up with the least common multiple for both 2 and 3, which would be 6. I want my oxygen to add up to a -6. I want my aluminum to add up to a +6, which means I'm going to need 2 aluminums, and I'm going to need 3 oxygens. And then the way I would write that would be Al2O3. Now, the shortcut way of doing that would be like this. Aluminum +3, oxygen -2. Crisscross the charges, bring that 3 down here, bring that 2 down here, and you get Al2O3. Just make sure that those components are in the lowest possible form. So reduce those down if you need to. The next compound we have is iron 2 sulfate. If I see the 2 in parentheses, I know that means it's iron with a +2. Sulfate, of course, is SO4 -2. So I have a +2, a -2. Those charges will cancel each other out, adding up to 0, and the formula would just be FeSO4, iron 2 sulfate. Okay, over here we have copper 2 nitrate. I know that means copper with a +2. Nitrate is NO3 with a -1. Now, I'm going to need these charges to add up to 0 to make a neutral compound, which means I'm going to need 2 nitrates for every 1 copper. The copper adds up to a +2. The 2 nitrates add up to a -2. That comes out to a 0 charge overall and a neutral compound. So the way I'm going to write the formula is, once again, copper +2, nitrate, NO3 negative, crisscross. That's a -1. I would bring that 1 down, but we really don't write the 1. But I am going to bring that 2 down here. And if I need to bring a 2 outside of a polyatomic ion, I need to put parentheses outside of that. So the way this will end up looking is like this. And the last example is barium hydroxide. Barium's in group 2. It always forms a +2. Hydroxide is OH with a negative charge. That means I'm going to need 2 hydroxides for every 1 barium, or just crisscross the charges. And if we do that, the 1, which is going to be presumed, we won't really write that, but the 2 is going to come down here. And don't forget, hydroxide's a polyatomic ion, so I'm going to need to put parentheses around it. And the formula will end up looking like